so first of all, how do you come up like with this kind of brief? Like, it's like very new in architecture that we use like a real like a scientific data to help with designing, or is it to the brief?
Can I really start?
Yeah, sure. Yeah.
So, in our profession, we mostly start from this narrative, quite a speculation, and we were thinking like how cool it would be to start from something grounded, something a bit more scientific. But speculation is still in it, but after we literally analyze it. Or maybe you're just gonna add something more.
No, that's pretty accurate. I also think, running a simulation only digitally can only bring you so far, I believe. I think there is a lot of value in using actual data, actual real-time data. That can be the source of your simulation, but it has to be coming from real data, I think.
Yeah, because like most of what we're doing in architecture school, we always like, well, how is this space view or something like that, but we don't really have like the data to prove like how it's the space view. Is it hot? Is it like cold? Or how does the lighting work? So using that kind of data would help a lot on designing the spaces. What else?
Yeah, it's like it's a good way to quantify those things. An interesting fact that we were reading recently was that architecture is one of the lowest automated professions.
Still very manual, very traditional.
It was right above a manual woodcutter, which is like bottom 20 professions or something. I think we can do better than these things.
Also, no mistake, like we don't say that should disappear. We just say there should also be a branch that is doing it in a different way. But also like, how do we design, and then how do we, because when you design, let's say a concrete building, a concrete structure, so the lifespan of your concrete structure, let's say, is around 30 years in such a hot climate, I don't know, maybe even less. And then how do you readapt it? How do you read this building? How do you analyze all of these things? And there, we believe there should be some kind of grounded data that we should rethink about it. Also, our material usage, and yeah, I think most of the time, like it's needed for this kind of things more and more.
It's also because maybe we live in Belgium at the moment, and we don't really build anymore. Everything is already built.
Flanders is full.
So we need to be very careful with how we have any impact on the space, right? So we want to maximize like profits. You know, we want, with the minimal amount of effort, we want to maximize architecture in a sense.
And the adaptability of your structure as well. That you need to think, maybe 30 years later, the community needs a different function, that your building should be able to react to that new function without having too much of energy and material consumed.
So that's why like the simulation is very important to like kind of foresee what's going to happen. So you use like computer to see what's going to happen and like how the design is going to affect the surrounding buildings and stuff.
The end goal would be, let's say we have 50 projects with 50 valuable digital heat maps of all kinds of data. This could be a potentially really good source to train a machine learning model that can then kind of properly optimize or predict a space, but based upon real data. So hopefully the results would make a lot more sense.